Okay, here's the last graph. In purple, I've got the graph of g of x, which is just my name right now for the cosine function. And I want to look at the limit as x approaches 0. Now, this one's not too bad. It's not even a piecewise function. I can trace my finger or my mouse across it perfectly fine. I don't even have to worry about division by 0. So I can say comfortably that the limit as x approaches 0 of the cosine function is 1. Again, I don't actually care that the cosine of 0 is 1. I'm using my limit idea. So coming in from the left, do I get closer and closer and closer to the y value 1? Yes, I do. Coming in from the right, do I get closer and closer and closer to the y value 1? Yes, I do. But I said I wanted to look at a hard function. So I'm going to go into my formula and I'm going to make this a little bit more complicated by adding 2 characters. I'll add a 1 and I will add a division sign. Oh, that'd be, well, there goes the effect. I want the function g of x is cosine of 1 divided by x. And with that little change, we get a very, very different picture. So Desmos is actually struggling a bit to graph this properly. As I get closer and closer and closer to x equals 0, 1 divided by x is going to get bigger and bigger and bigger, right? First it'll be bigger than 1, then it will be bigger than 2, then it'll be bigger than 3, then it'll be bigger than 4, and so on. And I've got to stuff all of those waves that the cosine function makes into this tiny little space. Maybe I can zoom in a bit to make that more obvious, but no matter how far I zoom in, there's just more and more and more of these waves that are sort of stacked up on top of each other. So I want to ask for this more complicated function, does this have a limit as x goes to 0? I'm back in the position where I cannot evaluate at x equals 0. So algebraically, 1 divided by 0 is not allowed. That is not a real number. You might call that infinity. And if I can't decide that 1 divided by 0 is a number, I certainly can't take the cosine of 1 divided by 0. But what I'm going to do instead is I'm going to use my limits and I'm going to trace along this graph. So let's start just here, say, x equals 0.15, y equals 1. And as I get closer and closer to x equals 0, my y coordinate goes all the way down to -1, back up all the way up to +1, back down all the way to -1, and so on. And you can see that, well, it's going faster and faster and faster. So Desmos is getting a little bit glitchy as I get closer and closer and closer. Computers can only see numbers that are so small. But knowing that the cosine function goes between -1 and 1, it makes sense to me that my y coordinate is continuing to bounce between -1 and 1. It's going to keep doing that no matter how close I get to x equals 0. And it's doing that on both sides of x equals 0 as well. So this is different from my pendulum at the very beginning of these lectures. The pendulum is approaching a resting point. And I know that because even though it overshoots by less each time that it goes. This function continues to overshoot all the way up to all the way up to y equals 1, all the way back down to y equals -1, all the way back up to y equals +1, and so on. This is not getting closer and closer and closer to a neighborhood of y equals 0. No matter how far I get here, I can always find an x coordinate where my g of x will be far away from y equals 0. Or any other y coordinate that I might want to try for the value of that limit. So for this problem, I would say that the limit as x approaches 0 of g of x does not exist. So we saw before there was a function that had the two different places that it could end up, and for the fact that the two pieces of the function couldn't agree, there's no limit. On this cosine function, there's not two different destinations we could end up. You might say that there are no destinations that we might end up. Fair enough. If you're comfortable with it, you could say that there are infinitely many destinations that we could get to, right? I can get as close as I want to this coordinate right here. And what is it? Y equals 0.3221. And I will hit that same y coordinate very, very many times as x approaches 0, but it still won't be resting there. It's not that we're getting closer and closer and closer to this coordinate exactly. The y coordinate just cannot make up its mind. So again, this limit does not exist. So let's move away from the graphs for right now and talk about how we would write this out. So I'll be using some slides for the next bit. See you then.